Okay, so in our problem we have 3x equals negative 4, square root of 4x plus 32. Wait a minute, is that right? Negative 4x plus 32, sorry. Okay, so we're just going to do some algebra here. I'm going to move this 2x, this positive 2x, I got to move it by subtracting minus 2x, which it looks like you had already done. So this side we're left with x equals square root of negative 4x plus 32. And my camera is having a really hard time focusing. There it is. Okay, so we have x equals the square root of this. So to get rid of this square root, I'm going to square both sides. Squared, squared. So here I'm left with x squared equals, the square root cancels, this square cancels the square root. So I'm left with negative 4x plus 32. I'm going to move this 4x and the 32 to the other side. So I'm going to have x squared plus 4x minus 32. And that's going to equal 0. Here I'm going to factor what's left. So I'm going to have two factors, both starting with x. They're going to be set equal to 0. The two numbers have to multiply to 32, and they have to give me a difference or a sum of 4. So if I put a plus 8 and a minus 4, I'm left with my factors as x plus 8 and x minus 4. So I'm going to set each one equal to 0, so that leaves me with x equals negative 8. This factor becomes x equals negative 8, and the other factor becomes x equals positive 4. And the question was asking us to find what is 5x plus 2. I'm just going to substitute this negative 8 into here. So negative 8 times 5 is negative 40 plus 2. That gives me negative 38. The other option is to substitute my 4 into this 5x plus 2. 4 times 5 is 20 plus 2. That equals 22. So I have two solutions here, and of the choices that are given, the 22 is available. So the answer is going to be our 22. And the other problem that's asking about the number of 3-digit numbers that can be produced where the first digit is greater than both the other two digits. Well, let's just think about it. We have 3 digits to use. If my first digit is 0, then this isn't going to work because 0 is not greater than the other two possibilities. So this one's out. If I start with a 1, then my only choice is where this is a 0 and this is a 0. So this is the only option when the hundreds place is a 1. If I give a 2 here, I can have 2 1 1. I can have 2 1 0. I can have 2 0 1. And I can also have 2 0 0. So when my hundreds digit is a 2, I have 4 possibilities. If it was a 3, then I'm going to have more options. So I could have 3 2 2, 3 2 1, 3 2 0. Okay. And I keep on 3 1 2, 3 1 1, 3 1 0, and then I would also need to do 3 0 2, 3 0 1, 3 0 0. So in this situation, when 3 is the first digit, I have 1 2 3 4 5 6 7 8 9 options. Now let's try with the 4. Can you guess how many options I might have if my first digit was a 4? There's a pattern here. So let's just try it. 4 3 3 432, 431, 430, 423, 422, 421, 420, 413, 412, 411, 410, and then 403, 402, 401, 400. So in this situation, when I have 4 as the hundreds place, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So in this case, I had the equivalent of 1 squared. Here I had 2 squared. Here I had 3 squared. Here I had 4 squared. And I got to do this all the way up to 9 squared because this is going to work for all numbers except where the hundreds digit is a 0. So I'm going to add the squares from 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared plus 7 squared plus 8 squared plus 9 squared. And if you do the math, this ends up being, let me see. Here's 1, 4, 9, 16, 25, 36, 49, 64, and 81. Add those, and you're going to get 1 plus 4, 5 plus 9, 14 plus 6, 20 plus 5, 25 plus 6 is 31, plus 9 is 40, plus 5 is 45, so my last digit's a 5, carrying a 4 now. 4 plus 8, 12, plus 6, 18, plus 4, 22, plus 3, 25, plus 2, 27, plus 1, 28. Answer is 285.